Good morning, good afternoon, and good evening, everyone. Greetings from the United Nations Statistics Division, and welcome to today's Global Network webinar. My name is Panya Yu, and I will be moderating this webinar together with my colleague, Alexander Loschke. Today, we are delighted to welcome Lalli Myllyaho from Statistics Finland and Ilana Lichtenstein from the Australian Bureau of Statistics. They will present on the topics of AI operationalization, machine learning operations, and large language model operations. This module is part of a series on the use of AI in official statistics, which we organize in collaboration with the AI and machine learning group of the Global Network of Data Officers and Statisticians. The use of AI and machine learning for official statistics is also dealt with by the United Nations Committee of Experts on Big Data and Data Science for Official Statistics. The UN CEBD for short provides strategic vision and coordination for integrating innovative data sources into official statistics production. The aim is to improve the timeline, accuracy, and granularity of official statistics and SDG indicators, while addressing critical challenges around data quality, privacy, security, and public trust. In this webinar, our two speakers will go through each phase in the machine learning model lifecycle, briefly discuss what they mean and how their careful or careless implementation can either promote or hinder responsibility in an organization's machine learning operations, or MLOps. This will also include theme starting from planning all the way to deployment and maintenance of the model. Special challenges and additional concepts of large language model operations, or LLMOps, will also be discussed. So I want to briefly introduce our two speakers. We have Lalli Myllyaho, who is the Senior Machine Learning Specialist at Statistics Finland. Lalli holds a PhD in computer science and works on advancing machine learning applications within the statistical domain. Ilana Lichtenstein is a senior data scientist at the Australian Bureau of Statistics. Her current work explores retrieval augmented generation, RAG, techniques for generative AI, the development of a reusable natural language processing pipeline for free text survey response analysis, and responsible AI. Ilana holds a PhD in bioinformatics. So before we start, just a few housekeeping reminders. This event is slightly longer than our usual Global Network webinar and will last for 1.5 hours. Our speakers will present for the first hour and 15 minutes or so, and we will then open the floor for a Q&A session. Throughout the presentation, please feel free to write your comments and questions into the chat box at any time. During the Q&A session, you will be encouraged to ask questions directly by using the raise hand functions, or if you wish, we could also read the questions out on your behalf if you want us to. This Global Network webinar is being recorded and will be made available on the Global Network on Yammer. I will put a link in the chat in a couple of minutes, and we invite you to continue the discussion there after the webinar. And with that out of the way, let me now turn over the floor first to Lalli for the presentation. The floor is yours, Lalli.
Thank you very much, Panya. And before I start the actual presentation, I'd like to note two things. First of which is that I only just noticed that while the description of the session mentioned the responsibility side, it was not mentioned in the actual title of the session. So if you're here for the solely on the MLOps and LLMOps side, don't worry. I think you'll still get things out of this session, but just note that the sort of responsibility theme is mentioned every now and then when describing the MLOps phases and what they bring onto the table. And another thing is that since we don't have that much time and we have a lot to cover, many things that are mentioned here are not going to like into very granular detail with. So please do keep that in mind. And if, for example, if you see something that seems interesting to you, please take notes. I'm in the impression that you might got the slides as well later on, but just so you remember what you wanted to look for, because a lot of the things are like easily foundable on, can be easily found online if you know what to look for. There are a few references I've added for things that might not be that, let's say, full online, but anyway, with that out of the way, today we're talking about, as mentioned, MLOps and LLMOps and how the life cycle of the models is handled and how that can either promote or hinder responsible machine learning in the organization's operations. There is a rough outline first. I'm going through the idea of MLOps and how it relates to responsibility overall. Then we'll go on to the phases in the MLOps MLOps process, from planning to data and data engineering to version control, validation, deployment, fault tolerance, and lastly, Ilana will go through some special considerations for the large language model side. As you can probably see, we're not going too much into the model engineering part because honestly, that's probably the part most of you are most familiar with, and also there's endless resources on that online. So we'll be focusing on the other things to save time. First, MLOps. MLOps it's a process description. That's what it is. It describes a process from the development to deployment and maintenance of machine learning model. And the idea behind it is that it's a spin-off concept from DevOps. If you Google, I think if I recall correctly, this is just a screenshot from Google image search when I typed in MLOps. The idea is that on one side, the model is developed. It goes from planning to data gathering and engineering to model development and testing the model. And then on the other side, there's the operations side. You deploy the model, you operate it, you monitor it, eventually you will run problems with it, and then you go back to planning and considering whether or not you go back to the development. So you not only develop the model, but then you will also deal with it online, and then you should take care of it while you do that. That's the basic idea behind the whole thing. And how does responsibility relate to all this? The first thing to note that implementing MLOps does not guarantee responsibility. It just doesn't. You can implement MLOps without it actually giving you any tools to sort of operate machine learning responsibly within your organization. It's a high-level concept. However, the responsibility of the outcome is predicated by the responsibility of the process, which means that if you plan the process carefully and you make sure the sort of show in the responsibility into the process, then the outcome will probably be more responsible, safer, and quite honestly overall better than it would be without it. And MLOps lays down the process, and with that sort of idea and pathway to the through the entire life cycle of the model, you can pinpoint things that will show where to consider responsibility and also how to promote it. And the mindful implementation of the process, it provides you with tools, not only on the technical side, but also organizational side and ethical side. Because all those things together link back to responsibility and link back to quality outcomes. So in short, implement responsibly. Potential benefits you have with MLOps with regards to responsibility start from just the basic idea that you will get a less risky production process overall. When you know what to do, when the people in your organization know what to do, the risk of them doing anything problematic by accident goes down significantly. They can focus on the things that are beneficial and crucial to the specific data and the specific model instead of trying to figure out every single piece by themselves when you have the process and the tools laid out to them. With the careful implementation of MLOps, you'll also get transparency and traceability benefits, which, well, if you have the process laid down and if the people know what they should do and when they should do, it's less likely that they will end up with doing just something, and when you go back to them and you'll ask, okay, you made the model, what did you do, where can we find all the data stuff you've done with it, which data did you even use, and then just answering, I don't know, I cannot recall. And also reproducibility. This is not only the idea of being able to reproduce the single predictions you have, but also the reproducibility of the entire system that's being built around the model and also the model within the system. Because, well, first of all, if you run into problems with your model, something happens, your computer crashes or whatnot, or your model is sort of coming out dated, it's not producing so good results anymore, and you'll need to start over. Being able to reproduce the old model also gives you pretty good hints where to start with a new one. So that as well. And overall, less hassle means less risk. Like I said, knowing what to do leaves less room for mistakes. When every single person in the organization does not have to think through every single thing every time, their job will be a lot easier. And when their job is easier, they won't get into so much trouble. And this is sort of promoted by the fact that once you thought about the process through within your organization, you'll not only have the process, but you will have the platforms and the tools and sort of ideas how continuous development and continuous integration is handled and everything like that, and which is not that model specific, but the broader ideas and broader tools that help your data scientists and machine learning engineers and whatnot do their job. Okay, with that out of the way, the first phase every time is and should be planning and the risk assessment, which quite honestly, it's boring, but it is extremely important. It leaves a trace of what is the goal, how to get there, which data, what severity of errors, the severity of potential errors while in production is, what ethical implications the things might have, what are the concerns you have. Not there's the, let's say, practical side to it, so that you know what to do, what's expected of you, and what is considered as a satisfying outcome. Because it's not once or twice when I'm seeing a situation where some stakeholder is ordering something, or something is discussed, but nothing is sort of, there's nothing tangible left from it, where the data scientist could return and see what's the actual goal. A couple months later, they come up with a sum model, and the original, let's say, customer says, okay, it's cool, but it's not what I wanted. Which means you wasted your time, you wasted their time, and quite honestly, they might not want to work with you anymore on such matter, because they gonna feel that you are kind of sort of you might not provide. But also there is of course, the responsibility side of things. If you can show that you've thought of things, you've planned of things, what can happen, what's the sort of risk, and how you plan to address all the ethical things that might come with it, then later on you're going to have, well, not fun, but let's say less awful time to explain yourself to others when and if something goes awry later on. Because you have something on paper to show that you've actually considered these things, and now just the risk came to fruition. Tough luck. One thing related to planning and risk assessment is that just a prototype is a trap. I recommend not falling for it. The world is filled with just prototypes that later on, when you try things out, you notice that there is some, let's say, ethical considerations or something potentially illegal or something like that. And you've basically made the model already, and it's showing promise in what it does, but it's questionable. And at that point, the best case scenario is that you've wasted time. The worst case scenario is that the higher ups still want you to implement it because it looks so good, despite it being ethically or legally questionable. So I would advise just prototyping without proper planning. From planning, we move on to data. We're gonna spend let's say, fair amount of time with this, as I've noticed that in many organizations where there are very capable people, like handling and training the models and coming up with good model architectures, the data side can still be a bit difficult to them, and what to do with the data and how to handle the data and so I feel that some tips may be valuable. You probably heard, all of you have heard some of these, but I hope that everyone finds something new. First of all, with the data, there's of course the ethical side. This is something that comes up in the planning phase, but it should be reinforced when you have the data on your hands. So recheck that the data actually is what it is supposed to be, and if there is something ethically questionable within it, then how to filter it out, how to make sure that it doesn't enter the system or sort of poison the model. And this, of course, includes like personal information, and the data should be non-discriminatory and non-biased. And there are a lot of like common ethical things that you want to avoid. For example, if you're working at least within the EU with the GDPR, if you accidentally let people's social security numbers fly around all over the interwebs, then you may be in quite a trouble. And also, if you are, well, I'm in the impression that many of you who are present work for the national statistics organizations. If your model ends up poisoning some statistic with some discriminatory stuff, then you might have some explaining to do how your statistics are being produced. But in addition to the ethical side, there's also the quality side. And that might not be as evident why that is a responsibility issue. But the thing is that part of the responsible machine learning is to make sure that your model is actually capable. If your model is bad, it doesn't perform, then I don't think that's a responsible machine learning. And with machine learning, the truth is, if you have high quality data, you'll probably find a model architecture that can learn it. If your data is garbage, then even a good architecture cannot really save it. But what does the data quality mean? And that's unfortunately highly contextual. There are some things you can check beforehand and say that, okay, this data is of high quality. But very often the proper measure of the data quality is just that can you or can some model learn the data? And of those common themes or common like ideas on what should constitute as high quality data is that the training and production data are actually representative of the phenomenon. Like if your training data does not match your production data, then you will probably not get good results in production, even if your model would be very good with the training data. And if they're not representative of the phenomenon, then the model cannot just come up with how the phenomenon should be handled. It's very much dependent on the data side. And things that you should at least check is that are all scenarios covered, or are there blind spots? Like in classification problem, do you have examples of all the classes? Or in regression, are there some, like, do you lack low values? Do you lack very high values? Do you lack something in the middle? Like usually, if you have holes or quote unquote holes in your data, then in those areas you'll be in trouble. Another thing that you should be mindful of is class imbalance, and that's kind of a difficult one because class imbalance in and of itself does not necessarily mean that you will have problems. If the classes are distinct enough, the model might just learn them. But if it causes problems and you're not aware that there is a class imbalance, you might end up with situations where you have no idea that you have the issues even in the first place. Like a common example is that if you try and predict two classes and your model classifies every single data point to class 1, and that constitutes of, let's say, 95% of the entire data, then the accuracy of your model is 95, even though the class number 2 was never predicted. And if you're not aware that there is this class imbalance and don't check whether how the model performs within the classes, you won't even know that you're in trouble. Tricks to sort of help with the quality side is, in some cases, data augmentation can help you, especially with images. If you have a picture of a cat and you mirror it, you have a picture of a cat, or you rotate it a little bit, it's still a picture of a cat. So, and also possibly with sound, if you add noise on top of people speaking, they're still speaking in the background, and the model might or should does have a slightly different surroundings around what's being spoken, and it can, for example, try and figure out what's being said or whatnot. With tabular data, this is more difficult. There are some tricks, but I would like to warn that it's more difficult with those. Data transformation. These are the kind of tricks that are, it's not really altering the data, but it's the idea is to transform the data into a form that's more digestible for the models. Here are some examples. I won't go into too much detail with those because if you look online, you'll find good and easy resources with those, and I do have to be wary of the clock, so take notes of those if you're interested in them. Imputation is a way to help with the data quality, but I advise again to be very careful, because first of all, keep your raw data safe, because if you accidentally imputate your raw data, you'll be in never-ending trouble. Because if you cannot know what's been imputed, then you'll never know if imputation was the thing that broke your model. And also you should be mindful of how you imputate, because let's say you have a numerical value. The first good guess is always 0. Okay, but if it's a let's say the variable was age, not a lot of people are of age 0. You could use average, but then again, that's kind of very affected by the sort of very big or small values, and it can be like not very close to a common person. Then a good guess could be like the most common value or whatnot. And all this, what I'm trying to say is that if you try to imputate null values with something, then be careful and mindful of what you're doing. In some cases you have to, because some models don't just take null values, like neural networks usually don't do well with other than numerical values, and if there's null, you're gonna have to do something about it, but make advised decisions, let's say. Then there's combining and dropping variables, which, for example, if you have variables that are co-effective, like things that represent time, like you have day of the week and hour of the day, you can combine them to single variable of hour of the week. Or you have correlating variables, like if the correlation is very heavy, then for a lot of models, it's actually easier to learn one of them than trying to learn both of them. You can run some principal component analysis on your input data to try and reduce the amount of the variables, but trying to keep the variance of the data. And also, since again, I'm in the impression that many of you are from national statistics organizations, and then you have a lot of content matter expertise within your organizations. So I would advise using their expertise on which variables are sort of not so important, so or don't really predict the outcome. So dropping them might actually help. And since this is a lot, there's a lot of stuff here, and if you're not really familiar with it, I would recommend a mindset where you think of all the data engineering as a funnel, where on the very top you have data gathering and all this broad stuff. Like, are we missing examples in certain classes and whatnot? Then in the middle you have the feature engineering stuff, like the data transformations and the dropping and combining variables and whatnot. And at the very end you have this sort of engineering that is something that the very model of your choice needs. Like, for example, if it needs the variables to be in certain data types or whatnot. And then the data engineering and trying to figure out the problems in the data and the problem how to make the data so that it is easier for the model to learn is sort of running up and down this funnel. And how to do that is if you don't have much experience, is that try and find a single model that learns the data somewhat. It has potential to be a model then, but it doesn't have to be excellent at this point. But then just lock it down. And after that, when you iterate up and down the model and retrain the same model with the changed data, you'll see how the changes you made affect the results. For example, you made it to the data transformation and the metrics got up. Good, save that. Dropped one variable and notice that, okay, the performance went down. Okay, reject, try again. With data engineering, you cannot try everything, so prioritize. And how to prioritize is all, first of all, is you have utilize the knowledge of different methods. Try and look for things that have worked before. Like online, there are people who share very openly what kind of data transformations have helped them, and when over time you learn yourself different kinds of things. What works, what doesn't, what works and when. Then the other thing that I already mentioned is utilize the content matter expertise. If the content matter experts tell you that these variables do most of the heavy lifting and these do not, and these don't really do anything, focus on the variables that have more effect. And then also utilize data analysis. If you can run sort of segmentations and whatnot where you can see does the variance of the distribution of the variable differ, for example, between classes. If it clearly does, it probably helps you with the predictions. If the distributions are all the same for all the classes, then it's just noise. And once the data seems fine, like you cannot figure out any big advantages anymore, then go back to tuning the model. Because now you've done a lot of heavy lifting with the data. Let's see if you can find the architecture that actually is the profound architecture in the said problem. And then if the further analysis shows that there are some more problems in the data, even after you've sort of thought you have figured out everything and now you're back with the model, you might notice something new. Don't be afraid of going back again. This is an iterative process. Then we'll move on from the data to version control. And with MLOps, the version control is, I think it consists of 3 things. There's data versioning, model versioning, and source code versioning. Data versioning, it basically means having snapshots in time. Like know when the data is updated. And because if you don't know what version of the data was trained, the model was trained with, you cannot know when your problems have begun. It might be that at some point in time, for example, some personal information have been leaking into the data, and if you don't know when that happened, then you'll gonna have a very rough time trying to figure out what to do with the data so that you know that there won't be any. And if you don't know when the problems began and you cannot figure it out, then you don't really have a safe point. Makes it even more difficult to figure out what to do with the data when you don't have any baseline. Then we have model versioning, which one huge benefit of which is that if you have versioned your model, then you can quickly switch back and forth. Problems begin. One thing is that if you notice that there's problems in the data, but you know which version of the data, which model version was trained with which data, then you can just revert back to the older safe version that was trained with data that was not poisoned. And not only is this actually important when something happens, but also it strengthens the trust, the organizational ability. What that means is that you can say and point out that you have a backup plan. When something like something happens, you have measures you take to go back to safer older versions or whatnot. Also, it leaves like a trace to be audited if need be. Like, for example, if someone wants to audit a let's say certain published statistics, and then there's been some older version of the model has been used to produce that statistics. You have the versioning done, you can show that, okay, it was that one. But if you haven't done anything, it's gone. You have nothing to show for it, and then let's say you might not be in endless trouble, but people are more skeptical. But also another sort of practical benefit is that since the old versions are still there, you can check what kind of things were successful in the past, which kind of gives you hints on where to start when you are trying to build a new better version of the model. And sort of you don't have to start all over again, but you can focus on getting sort of a bit better results this time around. Source code versioning, it's pretty much the same as for normal software. It's basic stuff. At the very least, I recommend you save the source code of the production version of the model somewhere, if nothing else. Then let's move on to validation. Validation it actually means two things in machine learning. First, which probably everyone knows, it's model validation. And then on top of that, there's system validation, which means validating not just the model, but also the software around it. Because in the end, I would say there is no case where there isn't a system that performs the predictions. Because at the very least, you will have some pipeline that passes the data to the model, and then some script or whatever that saves the results somewhere. And that's already a system. It's a very simple one, but it's a system. And the point of validation is, of course, to ensure that the model and the system utilizing it work as intended. And the as intended is actually an important part in this. There is an intention behind building the model and building the system. And not only do you want to know that the model works and the system works, but you want to know that it works as it was intended. And I really hope the link to responsibility is obvious with this one. As to the model validation, actually, from software engineering perspective, it's not really validation. It's usually more component verification, meaning that it's testing whether the component works. The part that makes it arguably validation is that if you design your validation procedure so that you try to reveal the intent behind building of the model, which quite often becomes more prevalent when we move on to the system, which is kind of why this sentence is here. But the idea is to test that the model has learned the data to a satisfying degree. And what the satisfying degree is very contextual. Because it depends what you're building the model for. It consists usually of these top-level metrics that are there to kind of assess that the model learns, like accuracy and F1 score, and for regression models, mean absolute error. And there are tons of these. You'll find plenty of resources online. I'd like to point out this book called The Little Book of ML Metrics. It's actually not yet published, but it's open source, and there's a incomplete preview is already online. And the point is that they try and gather the most of the relevant metrics into one place, because the internet is just full of it and it's difficult to find everything you want. So as a little hint, there's a thing like that coming up. But also in the model validation side, there is this these finer methods that are there to dig up the problems. For example, segmentation. Like previously mentioned, if you just look at the accuracy, you might lose information on how certain classes are performing. And if it's important that all the classes, or specifically some small classes, perform well, then you should check the sort of segments within the results, and also with regression, like check for low values, check for high values, check for middle values. You'll find more fine-grained information that will help you further develop your model. Then there's confusion matrix, which is helpful in trying to figure out why your classes are not performing well. It shows to which classes the wrongly classified things are being classified to. So it can provide you valuable information on which classes overlap and whatnot. Then one thing that is actually very helpful often is that pick a sample. Pick a sample of predictions that are not good and try to identify what's common amongst them, because that might just lead you to the root of all things on why there are problems within your model. And the closer to finishing you think you are, the deeper you should dig. So at first, if your accuracy is low, or your F1 score is low, you probably know that you have problems. But just because those are high doesn't mean there isn't something hiding, and you should look deeper into what's going on beyond the top level metrics. Then the system validation, and this is like actually validation from the software engineering point of view. And it's to ensure that the system works as intended and designed. And also to ensure that you did not break the model's results with the surrounding software. For example, I cannot mention the name of the media house, but I know a media house that they built this video recommendation system. The model worked. It was actually very good. But the system had an off by one error in it. So it provided the next customer with the video recommendations that were intended for the previous one, which of course means that those were not relevant to the person who got the predictions. But nobody caught that because the system as a whole was not validated, but they focused on the model. So make no mistake, it is possible. But then again, this is also highly contextual on what you should do with validation or validating the entire system. It's if the case is very simple, like if you just have a pipeline, the model, and the where to save the results, then it's quite a simple case, and at minimum, seeing that running the test data through the entire system gives you same results as you got when you develop the model, then you're in decent place. In addition, you should of course ensure that the stakeholders' requirements for the system are met, but like usual case, this is the minimum thing you should do. But if the case is more complex, you have some, let's say, a higher level thing, or for example, some sort of a chatbot or something that can answer, that people can use in very various ways, and which can provide very various results, then you should be more careful when you consider what you need and what the stakeholders need, and what corner cases there might be, and what actually might break the system. There are many forms of system validation, and how to sort of approach the idea of the system validation. I won't go into too much detail because I've actually written an article on them. But in short, there are different kinds of trials, simulations. The sort of, in the simple case, usually this kind of model-centered approach is quite decent. There can be some audits or like expert/end user opinions how to approach it, or any combination of these. Like for example, the using this sort of model-centered approach initially in the simple case, and then additionally having some trials with the end users on how they would use it, and if they manage to break it either on purpose or by accident, then of course your level of sort of a certainty goes up. Then on the deployment side, things to consider is, first of all, how's the model registry set up, where you store the model that is in production. Then another thing is that how the model is accessed, which means that when the model is in the model registry, how do you get to use it? Is it loaded in the code base and the memory when the sort of some script is running or the pipeline is running? Is there an endpoint that is accessed, or how do you do that? This sounds, and it kind of is trivial, but it's actually something that, for example, is affected by which platform you use, and how is that prepared for either one. So if you think, okay, just either way, then you might end up very annoyed when there's actually the point in time when you deploy the model and your pipeline should make some calls to it. But also one thing is that who can access the model? How do you limit that only the people who need the model and need to access it actually do? And this is probably even more prevalent thing to consider than how it is accessed. But also in the deployment one, you should consider how the continuous integration, continuous development is handled, which means that when there will be a new version of the model, how the integration would be as seamless as possible, especially if you have multiple systems that call the same model. Then I'm a bit running out of time, but luckily I'm also approaching the end. Fault tolerance. Fault tolerance are basically all the measures that are set up to prevent system failure. And what it means is that you have ways for error detection and error recovery. And this promotes the system dependability and transparency, and consequently trust and responsibility. And of course, the most well-known fault tolerance concept that is known within machine learning is monitoring. Monitoring takes, again, few forms. One is data monitoring that constitutes of like changes in distribution of a single variable, like variate drift, or sort of these situations where the variables by themselves don't really change, but they start acting in new ways together, which is called multivariate drift. And then they might be monitoring for completely new values. Like, for example, you suddenly have, let's say you start to have people or users who's, well, 115 years old or something like that, then that might be something interesting to look into. Then there's the actual model monitoring, which is like the easiest and most effective way of monitoring your model is checking your predictions against the actual values. If you get the actual values. With the statistics organizations, the sad thing is that often you don't, which makes this difficult. But if you have the actual access to some ground truth later on, then your life will be a lot easier than otherwise. There are performance estimation like tools and algorithms when the actual variables are not obtainable. This is a very new field. There's a reference. It's gonna be later on, but it's honestly a tough read. I put it there to show that there is science behind this, and it's not just fairy dust. But if you'd like to see some like more approachable examples, I recommend just Googling machine learning monitoring performance estimation, and you probably find something that is more readable than that paper, but it's there. You could monitor the output distribution changes, but that I find those a bit fuzzy as a metric of model performance, as if the model predicts like in a different distribution than earlier, but the predictions are still correct, that's perfectly plausible. It's kind of, if you have nothing else, it's better than nothing, but not a very good, my opinion. Then one thing you should be aware of is the concept drift, which is like when the relationship between the inputs and outputs changes, like the meaning of a thing changes. And these are the like difficult ones which you don't want to run into, and they actually might require an occasional sample that you check by hand whether or not things are changing, but they are very difficult to detect no matter what you do, just so you know. The thing with monitoring is these are often hierarchical. Like if you can see that your predictions against the actual values is changing, or the performance estimation is going down, or there's concept drift, it's more likely that there are some problems than if you check the changes in input data. But the changes in input data are, you usually want to do that because you want to find the root cause within the data after you notice the actual problems. But then there's the question of what then. Since I'm running out of time, I'm gonna run through very quickly. It once again depends what, when, how much. Sometimes just a small drop in things, it might not be that big of a trouble. You sometimes can ignore it, but be cautious. Retraining is, of course, what's usually done. But in some cases, for example, if you have a difficult time finding new data, then sometimes tweaking the model by hand could give you good results. Like, for example, in cases where you have a certain class within your data that, like, classification of which correctly is very important, then adjusting a little bit of the sort of prediction threshold for that specific class might help you. But I would again advise being very careful with this and at least discussing with a very experienced data scientist on how to do that. Then the last thing I have from my side is that there are other fault tolerance measures as well, which, like, it's not limited to monitoring and recovering from problems that are found through monitoring, but you could have deterministic rules for certain inputs. Like, if there are known problems with certain classes, but you have some deterministic ways of like handling those problematic cases, then you can, like, insert that into the system and not just let the model handle them. Or if you have some groups that are very easily handled with some deterministic rules instead of the machine learning model, then you can do that. Then if you have ways of knowing that the input or the output is obviously erroneous, so that, like, there can't be a null value in this column or something like that, then having some filters for them can help you. Model redundancy, basically meaning that you have multiple models that either vote, or if you have ways of knowing that, okay, these kinds of inputs are best suitable for that model or for that model, then having these input switches, or they would be bandit models, which basically, like, they battle for the place in the sun, or some recovery blocks where first model gives some erroneous results, then it's sent to another one or something like that. And if nothing else, I would always advise to have some failover options. Like, for example, if nothing else, if your model is offline for some reason, then you'll get an error message instead of saving, like, an empty database or something like that, so that you know that's happening. Another shameless ad, I wrote a paper on this as well, and here are the references, like the paper on the performance estimation, the paper on the validation methods, and on the fault tolerance, and then the little book of metrics. Like I said, other things are so that you probably, if you just search online, you'll find them by the name. And that's my cue. I was a few minutes over, and I apologize for that.
Should I pick up from here?
Yeah, over to you, Ilana.
Okay, thank you. Thank you, Lalli. Lalli spoke about MLOps, and I'm going to speak a bit more briefly about LLM ops. Lalli, do you want to continue sharing? Sorry.
Okay, sure. Just tell me when.
Now, just leave it up and I'll just tell you to click through. Saves me getting it up. Excellent. Okay, just next slide. Yes, so LLM ops. Okay, so you're probably all familiar with tools such as ChatGPT and Copilot, and these are just applications that have LLMs or large language models behind them. And they're often used to generate text. So we could ask Copilot to summarize our notes, or generate minutes from the transcript of a meeting. So LLM ops itself is similar to MLOps, is just a set of processes and tools which help to make the application, such as ChatGPT or Copilot or whichever application you might be running in your organization, more trustworthy and more responsible. So they're just tools, and like any tool, they can be used for good or not so good. It depends on making sure those tools are set up correctly and aligned to do what you want to do. And they can be used to maintain the quality of the text response. Just a quick note, LLMs have been advancing and rapidly, and AI generally, in the past 6 months even, and we've seen the rise of these reasoning class models such as O3 and O4 Mini, DeepSeek 1, and we've also seen the rise of agentic AI, where models can break down complex tasks and they can plan and are semi or completely autonomous and stay online without relying on user inputs. I'm not going to really focus on those applications today. I'm more just focusing on simple applications for LLMs, such as text summarization and question answering, where the LLM takes in an input and produces text as an output. So I'll just note most of what Lalli has said regarding MLOps will apply to LLMs as well. The difference is, of course, LLMs are generating text, so they have some additional tools available to control the quality of the application. But some of the tools and techniques Lalli mentioned, such as experiment tracking, model registries and validation, apply here as well. So if we move to the next slide. Thanks, Lalli. So this is an example of an LLM application with what's called a RAG architecture, which you may have heard of, which is a retrieval augmented generation architecture. And there's different types of RAGs, but what we've got, if we notice here, is on the left, we have model customization, and that's done offline, where you might generate your training and evaluation data set through your data preparation. You might take a foundation or third-party model from a site such as Hugging Face Hub, if any of you have worked with these models, and then you train it or fine-tune it on this model on your data. You'll have a training data set and an evaluation data set, and you get it to for example, summarize text aligned with your particular use case for your organization. So then we move to, I suppose, a production or live environment in that middle column where it says behind the scenes. And what happens is we're hosting the model. We've called it a foundation model or a fine-tuned model. And over on the right-hand side, the user enters a query. We process it. To ground it, we retrieve relevant documents. So, for example, a query might be, tell me the unemployment rate in Australia. And so the grounding step will go and say, well, which document in my knowledge base is going to give me the answer? And it might find some Australian Bureau of Statistics publications for the relevant period, the relevant demographics, and sort of add that into the prompt. And now the prompt itself will go to the model and say, answer this question, provide a very clear and concise output. And now here is the question. And the question is, what is the unemployment rate in Australia, which the user is given. So then we see coming out of that model's box, we have the LLM response itself, which might be the unemployment rate is whatever it is, and here's the evidence and reasoning behind this statistic. And then we have steps such as post-processing and responsible AI, where we ensure that the output is safe and doesn't contain any any toxic content or embarrassing content that the whoever is hosting this application, your organization, doesn't want your customers or users to see. So talked about so I mean one model we've got at the ABS at the moment is the whole of Australian government coda, which can take in different text, such as that someone will use to describe their occupation in a survey, such as I fix pipes, and the model will code that text to the classification plumber. And so you can see how these sorts of large language models can be very useful in national statistics offices. Next slide. Thanks, Lalli. So we just look at some key aspects of LLMOps, remembering that these are just tools and processes to ensure quality and sort of responsible practices. So a prompt, I mentioned the prompt before, so it's just a set of instructions to go into the LLM, and we can add some controls here. So there's a system prompt which is set by the developer, so that's us, and that might say answer, take the user's data and answer all the questions, only use information from particular knowledge bases, don't go out to the internet and use any other information, even if the user asks you to. We want you to answer in the tone of a teacher, ensure that you are very polite and concise, etc. So we can control the system prompt. And then we would have a placeholder within the system prompt. And when the application is live, the user will enter, say, their question, in this case, what is the unemployment rate in Australia? And that just gets sort of inserted into that prompt there. But we've already put the guardrails in place within the system prompt to kind of make sure we don't ask the LLM anything that will get it to misbehave. Next slide. Thanks, Lalli. Yep. So these system prompts, we can spend a lot of time engineering them and evaluating them to make sure that they do function to make the system generate accurate and reliable responses. And this can actually reduce the risk of model hallucination and some cybersecurity risks, such as jailbreaking, whereby the user can try and cause the model to produce behavior that you don't want it to, such as leaking sensitive information or generating toxic or hateful content. So there's a layer of protection, I suppose, with the prompt. Next slide. Thanks, Lalli. Another tool within LLMOps is something called reinforcement learning from human feedback. Due to time constraints, I won't go too much into it, but this is just a way to ensure the model text aligns to human human values and human expectation, and it usually involves training a separate, what's called a reward model, and the human can teach the reward model to praise our original model when it generates high quality text, such as text that's coherent. If it's generating an answer, the answer should be relevant to the question. The answer should be faithful to any context provided in the context window. And it's a way that this thing can just run while the application is live, and therefore feedback evaluation into the original model and sort of refine it as it goes. And again, the goal is to ensure that model is aligned with human values and what we want within our organisation. Next slide. Just quickly, I think Lalli mentioned drift detection and data model. So the model can change or the data could change. It's a similar idea when we're dealing with large language models as regular machine learning models. But if we think about putting something into ChatGPT, imagine ChatGPT changed the LLM behind the API from 03 to 04 mini, and suddenly the model changes and you've built this whole pipeline where you're calling that API. Now your system's behavior is going to change. So that's something else we need to be mindful of, and we can monitor that kind of model behavior and detect changes too, which can set off alerts and tell us we need to go and have a look at something. Next slide. Thanks, Lalli. At the end, we have response post-processing and safety checks. So once we generate text, before it goes out to the user, we can check it for safety to make sure the text is not toxic, hateful, and if the risk is above a particular threshold, again, we'll have to use a model to do that because you're not going to have a human sitting there every time, but the model can score the output text for these criteria, such as toxicity, for example, and if it's above a certain threshold, we block the response. And again, all of these automated evaluation tools and models have to be aligned to human feedback. Can't get humans out of the loop. We have to be in there at some point. Next slide, thanks, Lalli. This was just the earlier RAG application that we showed, and you can see on the left where you can see I've added in the LLMOps tools and processes and where they fit into the architecture. So the prompt engineering can help us on the left, and we've got RLHF and drift detection, MLOps, automated checking, various other tools that can be used throughout the application architecture, as guardrails to ensure our system is responsible. Next slide. So LLMOps just fits within a subset of MLOps, I suppose, and it's all part of responsible AI. Nice little egg-shaped image there. Next slide. Thanks, Lalli. Nearly finished. And next slide. So again, this is just repeating what I've said throughout. LLMOps enables responsible AI. It's not separate. It's just tools to enable responsible AI, and it's up to your organization to decide what responsible AI means to you. So prompt engineering, we talked about the role it can play in the system prompt to ensure accuracy and security and reliability. I've put in blue different themes of responsible AI. We didn't really cover them here today, but so accuracy, for example, is in blue. There's different aspects to responsible AI. RLHF goes toward accuracy and alignment, and response post-processing can go toward ethics. And drift detection model, for model and data drift can go toward system reliability. So you can see reliability is a different theme of responsible AI to ethics. So all these tools will address one or more themes of responsible AI. I believe that's it. Next slide, Lalli. Yes, it's it. So this is our contact details. And I think we have 10 minutes for some questions.
Yeah, thank you so much, Lalli and Ilana, for your very rich, thought-provoking and very timely presentation. I think as organizations start to adopt some of these tools, it's very important that they put a lot of effort into getting things right. So now we come to our Q&A session. I have changed the setting to allow you to unmute yourself and turn on your camera. If you have a question, please do use the raise hand function at the top of your screen. Any questions to break the ice? As we wait for hands to go up, perhaps we can take some of the questions that are in the chat box. There are a couple of questions from Christina. Christina, are you still around? Do you want to just unmute yourself and ask these questions yourself?
Sure. Good morning. I think I'm not going to turn on my camera because I'm just on my phone. So that's always a little disconcerting to have that fisheye look. But I think the first question that I posed was about integrating ethical considerations when Lalli was speaking. But I think in a way Ilana's answers or Ilana's discussion presentation helped to answer some of that. On the second one, it's really just looking for tips and tricks, sort of heuristics on especially the data validation step. I know any tips or tricks, I think that would be helpful from a technical, having gone through it probably more than me. If either one of the speakers actually sort of have heuristics to share, things that they know now that they wish they knew earlier, that would be lovely. Other than that, thank you so much to the speakers and to the organizers. This was really excellent.
Thanks, Christina. Lalli and Ilana, any one of you want to take on this question about tips and tricks?
Could do just a bit on the validation. I mean, the only tips and tricks I would say is prepare a very wide-ranging validation set to cover a lot of rare examples. Also, you could search for publicly available data sets that you could, where someone else has sort of attempted a similar task to yourself. So it might be a data set produced in another country. So often, the quality and breadth of or coverage of the data set will help you with your model validation. I think, maybe Lalli, you can do data version control.
Yeah. One thing that I found very almost soothing in the data version control thing is that using delta labels actually handles a lot of it for you. Because whenever you alter the data within the delta table, it actually saves a new version of itself, and you can time travel within it. I believe it's under the hood, it's like Parquet files along with some metadata that do the versioning. So that I found very helpful. And something to perhaps add to I think in the chat you said model validation. And a thing with that might be useful also is to sort of recall the intent of the model and focus on what that means. Because for example, an example of a spam filter, like an email spam filter. If you decide that it's more important to catch most of the spam, and that's more important than to have some false flags, then choose the metrics based on that. Like I always get mix up which one is recall and which one is the other one, but sort of kind of aim to validate what you actually want the model to do.
All right, thank you. Let me try to get another round of questions. Please do raise your hands if you have any questions for the speakers. I still don't see hands. Ilana, were you saying something?
Oh, I'm trying to go through my Spotify podcast list now because I often just listen to podcasts on the way, to work, and that can just be very helpful. They'll tell you about a new library, a new open source library or platform that's come out to manage your data or your experiments. If I see any more, I'll put them in the chat. Gradient, yeah, it's another good one.
Yeah, great tip. I still don't see any hands, but I see that Christina has a follow-up question. And she said maybe another question would be how to keep up to date on prompt hacking / injection. Yeah, I think you were answering that question already.
I think this is a challenge. If I can just add one thing too, is that I know at the Australian Bureau of Statistics with that, it's probably the same everywhere. You've got your cybersecurity professionals and your machine learning practitioners, and we don't always sit in the same sort of room. And I think things like prompt hacking and injection is probably something where collaboration would be helpful. Sorry, there's another question.
Yeah, there's another question from Martin. Martin, would you like to come in and ask that question, or you want me to read it? I don't hear from Martin, so maybe let me just read it out. How do you sell internally the use of an external LLM access through an API, considering that you don't know beforehand how much it will cost? Or do you use local LLMs? Any thoughts on that?
Well, what I've done is that you sell it first as a like this very small project where you A, try to see how it works, but B, also you get the information on what the cost is with a, let's say, certain sized set you have, or even, well, the platforms usually have this like token counters, and you get the information on how much one token costs, so you can like calculate how much it is with a subset of the data, and based on that you can assess how much it would cost to run the entire thing with, and then you discuss it whether or not it's feasible or not.
Thanks, Lalli. I think we're almost time, so I'll take one last question if there's anything on the floor. If not, perhaps if you allow me, I'll ask one of the questions that have been pre-submitted in the registration form. And this has to do with sovereignty. So the person who asked this question, I think, comes from the Netherlands. They said that Dutch governmental organizations are more and more aiming to maintain sovereignty with respect to their IT infrastructure. What advice would you give to governmental organizations that aim to be successful with data science, analytics, and AI, but within the context that the platforms from other countries are minimally used? Any thoughts or advice on, kind of trying to make sure that these governmental organizations limit the use of tools, I suppose, developed or controlled in other countries?
it's very, very difficult, but I think that's probably country specific. So, I mean, the Netherlands might have more options than, say, Australia. I'm not sure about Finland, but we would normally just, if we're using a cloud, you have your, your hosted, your virtual environment, your, secure private cloud, which is, so you adhere to local data sovereignty laws, which says, the data has to remain offshore. But in terms of using local tools, local platforms, local products, I'm not sure if that's not quite the question, but then, I mean, it's a bit harder. But Lalli, did you have an answer to that one?
First of all, question is quite broad. Like if you'd like some advice on the hardware side, that's at least I'm not that much of a hardware expert, like in the sense that if you're building stuff in house, if that means, if the IT infrastructure means also like the actual machines, then I'm not that much of an expert. But if it just means that as much is done, like building the software locally, then it might actually, I think like giving a satisfying answer would require some more context on how much is built. Like in the house, and like I said, if it's all the software, or is it just trying to have like very few like widely capable software that are helping with building the other software, or is it building the entire hardware ecosystem by themselves? Then it kind of, the answers might vary.
Now it's a tough question, and I think Ilana, your further comments that it costs many billions of dollars sometimes to kind of train some of these models or to create some of these products, and it's only a handful of tech companies that will be able to do that. But kind of the more important thing is probably to make sure that these tools are used properly. I think that's a fair statement.
Yeah.
But this is a very hard question. I don't think we expect any correct answer on that.
Yeah, maybe one thing regarding the LLMs is that I'm in the impression that at least some of these large tech companies actually do have sort of version of their platform that can be run locally. So you kind of buy the license to run it locally, and then it's in your own premises, but then that again requires enough computation power, and that's not something I'm that familiar with myself. Like I have never tried to run any of the large tech company built platforms locally, so I don't know how it actually happens. I'm in the impression that it is possible, and they do provide that service. And if that's something that's useful, but
yeah, I'm just thinking, if I think about it, we tend to use smaller fit-for-purpose language models for specific tasks, and they would be hosted locally. But if you're talking about OpenAI, you would use the API but then you can't, you can't use that with sensitive data. You can't sort of use the general OpenAI API and just send off, your the organization enterprise data. So you can only do that outside our, secure environment, in a public, in a separate sandbox environment. But I was just thinking about the question about locally hosted models, and we do have a lot, but they tend to be smaller. They're not sort of the O3 or the O4 or, the Claude Opus or what, those very large, powerful ones. We tend to use APIs, but again, for sort of public data exercises. Yeah, it's a tough thing. I think everyone's trying to work out exactly which tool to use for what task and where to use it. So,
yeah, definitely it's a work in progress. I'm mindful that we're about 7 minutes over time right now, but it has been a very, very good kind of conversation full of information. I know that it's a lot to digest. So we'll definitely post the recording and the presentation in the global network after this. But for now, I really appreciate your time, Lalli and Ilana, to come and speak to the members of the global network on a fast evolving topic. And as usual, as is our habit in the global networks, can I just ask the participants, for those who are able to please unmute yourself and turn on your camera to just give a big round of applause to our two speakers. Thank you so much, Lalli and Ilana.
okay, thank you.
And thank you everyone for taking the time. The Global Network will be back in July for one more webinar before we take a small break for the summer. But hope many of you will join that. Please do look out for information in our announcement. Thank you again, Lalli and Ilana, and to everyone else, thank you for joining, and goodbye.